All right, in this section, we'll be discussing the real applications of normal distributions. So what do we do when we have a normal distribution that doesn't have a mean of 0 and a standard deviation of 1? Or maybe it has one or the other, but not both. The simple answer to that is that we're going to standardize everything using z-scores. So you are going to take everything you're working with, every value x, and you're going to change it into a z-score. This will allow us to standardize everything, and we will be able to use our nice, lovely charts. All right, so when you are converting any non-standard normal distribution with a mean, all you have to do is just use those z-scores. So again, it'll be much easier when we show you how this all works in examples. So the procedure for doing this is just, again, to make your sketch, label everything, label your mean, label any specific x value, shade the region that you want so you remember what you're using. For each relevant x value that they give you, find that z-score and then use either technology or your table to find the area of that shaded region. So let's just jump right into an example. All right, the heights in men are normally distributed with the mean of 68.6 inches and a standard deviation of 2.8 inches. Find the percentage of men who are taller than a shower head at 72 inches. Okay, so for this problem, okay, we have a normally distributed, right? It says it's normally distributed. It has a mean of 68.6 inches, and it told us the standard deviation was 2.8 inches. Okay, so we want to find the percentage of men that are taller than the shower heads, which are at 72. So they want to find this area over here taller. Okay, so we're gonna find the z-score for 72, and then we're going to use our chart or technology to find this area to the left, and then do 1 minus. So we're going to use the complement there. So first thing we need to do is calculate the z-score. So the z-score is going to be our height, which is 72, minus the mean over the standard deviation. And that, when we round it to 2 decimal places, because we know our z-scores are always 2 decimal places, is 1.21. All right, so now I'm going to have to go look at my positive z-score page on my table and find the percentage that corresponds with the z value of 1.2. So when you do that, and you go look at the table, you get, and again, remember, when you look at the table is going to tell you this area to the left. So we're going to have to do 1 minus whatever that area is. And that area, when we look it up on the table, is 1.8869. So we're going to subtract those, and that will tell us the area over here in purple that we're looking for. And so that is 0.1131. All right, so what does that mean? Okay, find the percentage of men. The percentage of men who are taller than that 72-inch shower head is going to be 11.31. Now, if you use technology, it might give you a slightly different answer. So if you use technology, it might give you, instead of this answer, it might give you 0.1123, which is still very close because they're still within 0.1% of each other. So just know that if you use technology, it might give you a slightly different number, but still very, very close. But please know that when you are assessed, either of those answers would be considered correct, depending on if you use technology or not. So very important to, when you're taking your assessments in these, to be very clear about if you're using technology or if you're using tables, so that your professors know the difference. Because I would look for both when I'm doing the problem. All right, so here's just some helpful hints for those cases when you're finding areas. Just again, make sure you're drawing those graphs, those little sketches that really help you figure out where you're going. Again, don't confuse your z-score and an area. They are different. The z-score helps you find the area. The z-score is just the distance away from the mean in standard deviations. So we want to make sure that we don't get those things confused. Remember that you have to pick the correct side of the graph, whether it's to the right or to the left. So remember, the tables will tell you the area to the left. So this is very important. So there's just all of these things that you have to keep track of. So it's very important that you understand visually what's happening. Remember, when a z-score is negative, it must be below the mean. If it's positive, it must be above the mean. And that the areas or probabilities should always be between 0 and 1. So if you get a probability of, negative 0.2, you've done something wrong. Or you get a probability of 1.7, okay, that's not going to happen. So just, again, keep all of these things in mind. So make sure you sketch everything out, label everything like I did in the last example. If you're using the table, please, make sure that you tell me I'm using the table. Make sure you show your work. If you need to, if you take the z-score and you formula and you kind of move it around, you can also use it this way. So if they tell you this z-score and they want you to find the x, you can just plug in your z-score with your mean and your standard deviation and find the x. This is actually the same formula as z equals x minus mu over sigma. So it's the same formula, just feng shuied a little bit. But again, make sure that you're always looking back at your sketch and making sure that your problem makes sense. All right, so here's another example that involves all of the same stuff. So when you're designing things, one of the criteria for design is that your design has to accommodate at least 95% of the population. So the question here is, what is the height of a door that would allow 95% of adults to walk through the doorway without bending or hitting their heads? Because obviously people like NBA players, like we can't make every house to accommodate an NBA player. Because that would just be ridiculous, right? Because all of us are not, 7 foot plus. So we have to think about these things. Using the data set that we have in our textbook, assume the heights of adults are normally distributed with a mean of 66.2 and a standard deviation of 3.8. How does the result compare to the door height of 80 inches, which is required by International Residential Code? Okay, so we have this normally distributed population of people with by heights. Okay, the average height of adults is, the mean is 66.2. So let me label that, mean is, and the standard deviation is 3.8 inches. Okay, so we want to know what will accommodate 95%. So there's some z-score here, I don't know what it is, that this area over here is going to be 0.95. Okay, so that's the first thing we have to look up. What is that z-score? So we're going to go to our chart, or we're going to use our technology, or whatever it is. And it turns out that that z-score is 1.645. So we're going to use that. And again, if you use technology, it'll tell you right away, right? You can just plug it right in and it'll tell you. If you're using the table like I usually do, then I would have to use that little formula, right, that I just talked about in that previous slide. All right, so I know my mean of my population plus I'm going to take that z-score and I'm going to multiply it by my standard deviation, and I'm going to plug that in my calculator, and that is going to tell me that I get 72.5. Well, if you round it, it's 72.451 if you want to get technical. So if I would round that, I probably would round that up. And I think it depends on if you're using the technology, it might actually round it up for you. So that is the height of people right here. So 95% of the population is going to be below 72.451 inches. So technically, we really only need to have the doors to be 72.45 or 72.5. You'll probably make it easier if you have rounded to a half an inch. That would allow 95% of the adults to go through. But the second part of this problem asked us to compare it. How does this result compare to the door height of 80 inches? Well, that's much lower, right? 80 inches gives you an extra 7.5 inches of clearance. So that means that the International Residential Code is actually more than 95%, right? Because if this was 72.5, here's 80 up here. So there's more than the 95% that we had. So notice how drawing the sketch of the situation can sometimes help you figure things out. All right, so you can go practice this, and then hopefully I'll see you in the next lesson.